Okay, a few yous asked me the other day to do the amortization formula, but obviously it was one of the things where other people were worried about other things, thought this might not come up, and we'll just see. We will. I don't know if it's going to come up. We don't know, but I will do it out here, as I said, so that you're not stuck. Basically, you just have to do it as if it was a normal question. The amortization formula on page 31 of the log tables. You know that you can use it to fill in for, let's say they give you like the question is someone takes out a mortgage for a certain interest rate for a certain amount of time. You could take all that information and sub it into this formula here for the P, I, and the T, and it will tell you what A is, and A is the amount that they have to repay. As you see, now here it says annual repayment, and that's why it's the A, I guess, but we very often don't use it for the annual. We very often use it for monthly. So it's the same thing, don't worry about it. It's just that the T will be different. If it's 4 years, it'll be 48 instead, because it's 12 months in a year, and just work off of it from there. Now in a mortgage or a loan, we're going to use this formula here, this guy, because every payment that you make, we want to find out how much of that payment is actually going towards the original guy, like the actual loan amount, and we're going to knock off a certain amount that is the interest that we don't care about. And this formula here, because it works in the reverse of the original guy, instead of adding the interest on like the first one does, the second one will take the interest off. So we know that if the first repayment you make is A, and we're just going to keep the A in line with what they have. I think you can read that. I don't know if it's too small, but it is on page 31 of the log tables. A in place of the F, we use, now again, in a normal question, what you can do is use the I and the T like normal, but what I'm going to do is, that's incorrect. What I'm going to do is, I'm going to do out the question like as if I was using real numbers, but I'm just going to pretend that no, we don't have any of the numbers, and that's where the proof of the formula comes from. But basically, you'll notice each month that you have, every extra month you experience will have another month of interest that you'll have to get rid of. So month 1 would only have 1 month, so that's why it's to the power of 1. Month 2 will have 2 months, that's why it's to the power of 2. Month 3 will, I think you know where I'm going with it. This month 3 will have 3, that's why it's to the power of 3. And then we're not going to do all of them, but the last one would be month N, if you get me. Maybe I should have made the 1, 2, and 3 smaller, but it's like month 1, month 2, month 3, month N. Then in that scenario, it would be the final monthly repayment will have to knock off N months worth of interest to find out how much of that monthly repayment is actually going towards the original amount. So if each time we do this, what we're doing is we're finding out how much of the A in that month is going towards the actual loan amount. And when we divide by this number, what we're actually doing is taking off the interest each time, right? So that the amount that's going towards the interest we'll never figure out. We're just going to knock it off the monthly repayment. So all of these guys added together will hopefully be equal to the full amount of the loan without interest. We don't care about interest. So in the real question, what you would do is you would use the amount of money that the loan is worth. But here we're going to use P again, because none of the things that I'm putting in are actual numbers. You're putting in the 1, 2, 3, sure, but you notice you're putting in the N because they could put in any amount of months, any amount of years, but then you'll notice that makes a geometric sequence where A, the first one, is A over 1 plus I to the power of 1, and or the common ratio, the number you're multiplying by each time, is 1 over 1 plus I, because each time you're multiplying by 1 on top effectively and 1 plus I on the bottom. So we're going to make an SN formula out of that using the geometric sequence SN formula. And it's like that, and if we fill all of that in, the SN is what we all wanted to add up to, and you'll notice that is the P, because we wanted all the numbers set up to P in the thing. So I'm going to put P in here. Small a is the capital A over 1 plus I. Now to the power of 1, I'm probably just not going to do the power of 1 because this looks very messy as it is, so I'm going to try to leave out as much as I can without interfering with the actual question. Just hopefully it'll just make it a bit cleaner, because there is going to be a lot of brackets and nonsense floating around here. Like for example, that's or going to be to the power of n. because the n is only on the or, not on the 1, so you have to kind of specify it. That's why that fraction is in a bracket. And then we're going to have 1 minus 1 over 1 plus I. Yeah, I think that's right. Now, the whole goal of the amortization formula is to get a on its own. So, like, in theory, it's handy enough because all we have to do is move everything that's not a to the other side. The problem is, this is all the not a. So we're going to have to move all that. Now, we're going to do it bit by bit. Do I want to do this separately? There's a few things I want to do. I don't know how to lay it out here because I don't know how you want to lay it out in the exam. What some people would like to do is put that together first and make it one single fraction. Do I write it on the side though to kind of illustrate how to do it? I guess, right? So I'll just do it here for now anyway. I'm coming back to here. I'm just kind of like doing it. Go up here, get the answer, and slap it back in there, just to kind of highlight the specific part of it, if that's okay. So I'm just focusing on the bottom of the fraction. You'll notice we have this guy. If you remember, anything though can be made into a fraction like that by putting it over 1. And if we want to add these, they have to have a common denominator. So I'm going to multiply this guy by 1 plus I on the top and the bottom. This bit no, I think this bit is kind of necessary in the long run. Some people would do it later on, I think, but you'd end up with this. But because they have common denominators now, you can just reunite them as one big fraction with the same denominator on the bottom. That's just adding and subtracting fractions together, and you'd be left with 1 over 1 plus I. Sorry, it should be 1, or no, it's I over 1 plus I. I said 1, I think, I can't remember. But that is what the bottom bit turns into, so what I can do is rewrite out that again, but just sub that in instead. I'll probably do it in the next line, because I also want to highlight this thing. So it's 1 over 1 plus I to the power of n, but if you think about it, 1 over anything to the power of n, according to the log rules, page 21, second last one on the left column, it will tell you that it's 1 to the power of n over a to the power of n. That's the same thing. But then 1 to the power of anything is still going to be 1. So it just becomes this. So basically, if you have a scenario that looks like that, it will automatically turn into this. So here, what I can do is I can get rid of that and replace it with 1 over 1 plus I, where just the power of n is on the bottom, because the power of n on the top would be completely irrelevant. But again, I'll do that in the next line. I don't want to clutter it up. I'm just kind of explaining the 2 steps I'm going to do here, because it does get messy. Now, when you're doing it, you don't have to highlight that as much to them, because obviously they will know what's going on. You want to do it as best you can, but I understand if people try to do it in the middle of this horrendous fraction, they can lose sight of things very quickly. But I'm just going to condense it slightly to look like this. Some people would consider it's not even condensed, just kind of like it's still roughly the same amount of shit. Now, again, there's different ways of doing this, you know, and the way I like to do it is, and I don't know if this is going to stress people out, what some people would do is they would take this guy and they'd say, oh, I'm dividing by it, so I'll move it up here and make it multiplying instead. And that's fine. I might do that, actually. I will do the rainbow bit to be like what's going on in my head, and I'll tell you what I would do. I would say I'm dividing by a fraction, and instead of dividing by a fraction, that means you can multiply by the fraction flipped upside down. This is one way of doing it, and you can go with this if you want, but I would probably do it the other way afterwards. So I would say, okay, instead of dividing by this, I'm going to multiply by it upside down. And then what would happen is, because technically this is fraction being multiplied by a bracket being multiplied by a fraction, it's just 3 things being multiplied together, but we'd end up with a 1 plus I on the bottom here and a 1 plus I on the top here, so they would cancel out. And you'd end up with like the a being multiplied by this fraction all over the I. You would, if you were doing it this way, you'd end up with this. Again, that's some people would think that's messy, because then we're going to have to bring the I up and multiply by it anyway. Oh, fucking balls. Okay, so yeah, I think that's how I would do it. I'll be honest with you. I know there's a bit of pause there. I'm just trying to think whether I want to just carry on doing it that way. Because I'm aware if you're not knowing what's going on, it's going to look like a mess for me to just like undo that now and go back and do it the other way. But if you understand what I've done there, you could do it that way. Yeah, if you understand what I've done there, you could do it that way. Bring the I. I think you'd know to bring the I up and multiply the P by I, so you'd end up with like an I on this side, and then divide both sides by this thing, and then it does just it is messy though. It is messy regardless of which way we do. Yeah. Yeah, I might stick with this way actually. But now I'm not happy with how I wrote it. But yeah, I'll stick with this way. Yeah, we'll go with it. Sure, why not? We'll go with it. I know it's a bit of a mess, but you know what? I was gonna clear this shit, but you can always just rewind it to see what was there. So I'm gonna actually leave it. Yeah, that was my main issue. I was thinking it just looks awful now, but you guys can always rewind it and see what I did. Yeah. So, because if I try rub stuff out, it's all just gonna be a mess entirely. It's all gonna be all gone. So that's still equal to. I'm gonna, I guess, return to the green pen. I didn't really plan on doing it this way, but I do this and then multiply both sides by the I. So look, I'll write it out one more time just to kind of make it clearer. You notice we end up with this. Now, the problem is, again, we have, like above where we had the 1 minus the fraction, so I took a 2 and a side and we did it out. That's what I'm going to do here, but I'm going to do it with this shit here. And you'll notice that basically it would look like this. Now, in a rather weird way, again, this is over 1, and we want to multiply on top and bottom by this guy, which it seems gross to introduce more of these with the power of n's, like this unknown. But it's the way they have it in the thing, so... you know, I'm sure different people would prefer it written in different ways, but, you know... just different people... and then you'd end up with this. In the same vein as above, it's the exact same thing that I did above. It's just like it's looking weirder because it's the power of n. I think if you could do the first one, you'd be capable of doing the second one here. So if you're stuck at this one, look at the first one again and just see how it's exactly the same, if that's all right. Then we put that in instead of the entire bit inside of here. Yeah, look, it does look like a mess. Yeah, I hear you. But it's just how it is. Now, there's different ways of going about it, but basically, if you think about it, right? If you think about it, what you could do is, if you're multiplying a, you could treat this as a over 1, and make it like into this kind of weird looking thing here. I'll tell you, the point that I'm trying to get across is the bit on the bottom, we can just, because we're dividing by it, we move to the other side, it becomes multiplying. So we'd be left with, if we bring this guy up to the other side, make it multiplying, we'd be left with this. Keeping in mind again, the whole point is to get a on its own. And then you divide everything by this guy, you know what I mean? You divide both sides by this guy and it would cancel out. I'm just going to do it on the next line to avoid it. I'm aware this looks like there's a lot of shit going on. And you might be asking, surely there's a way of condensing it? Maybe. You see, there's certain steps that they would know how to do. So there'd be certain things that I could skip that someone who's like, you know, been doing maths for years would be like, oh, I know what he did there. I can see what he's doing. I know what's going down. But for me to explain this, particularly the red bits, I had to kind of weirdly dip into doing algebra and just teach algebra again to remind you that technically the green part is the proof, right? But I don't think you guys would just be able to see how this thing turns into the fraction that I wrote out and inverted over here. So the red bit might be necessary. You definitely don't need this bit. I just need to highlight for you guys to know that. You just don't need to necessarily write that. You know what I mean? Like the red bits are just kind of, it's like rough work that's not necessary, but it's necessary for you guys. It's not necessary for the marking scheme, you know. Actually, I think there's brackets down there I can get rid of, I realise now, just because again there's a lot already, so if I can get rid of as much as possible, that's handy. But again, the aim was to get A on its own, so technically we're done. Now we're going to see when I pull this down, and I'm going to get rid of that arrow because it upsets me, but you're going to see that we have now this upsets you guys. I have it like literally mirror image style, but it's fine. It's perfectly fine. It's still A equals and all the same elements. They don't have P in the fraction. That's fine, because again, remember what you could do is treat the P as P over 1, multiply the P on the top and the 1 on the bottom, which would give me this. This is perfectly legitimate formula. If you want to at the end, if you're that way inclined, you could just rearrange it and write, well, that means A is equal to the P in the same way that we can put it on top of the fraction. We can also just rip it out of the fraction. The I would be there. 1 plus I. Now I used the power of n, but they used the power of t, which is fine. It's just I denoted the same amount of time with just a different letter. If you want to write it with the t the entire way through, instead of when I used the n at the very start, you could use t. That's fine also. But you'll notice that that is the proof. That is the end result. That is the goal. And that is technically on the course. I think it came up in like 20... can't remember, to be honest with you. I was going to say 2018, but that's not true. But yeah, there you go. I don't know what you think. I'll probably do another video on well, do I kind of just hold on now, this is creative thought process you're here now for the first hand. Do I just do all the financial math stuff while I'm here, and then if you don't want to do if you're only here for this, you can be here for this. Yeah, well, I haven't thought about it, so I'd be afraid to jump into it. So yeah, we'll just cut it short here. This is just the amortization formula. I'll do financial math some other point, I'm sure.